energy. Lifelines feeding the world's urban centres. Signifiers. A blaze of lights. Power to drive production and trade. A web of cables to turn night into day if need be. But major disruptions do occur. Metropolitan areas thrown into disarray. Some areas even plunged into darkness.
Power went out at about 5 a.m.
And there's no coffee.
Others were forced to sit out the morning trap. Lunch cooked in the dark at this Cherrybrook retirement home. No power, no heating, time to rug up.
These are incidents utilities fear and hope to avoid. How? Most basically by safeguarding the cables. If an underground cable gets too hot because its surrounding soil retains and amplifies the heat being generated by the cable, then a costly loss of power will occur, and correspondingly, the asset, the cable's performance and reliability, is greatly diminished. Precautions must be taken at the outset. When electricity cables are to be installed in the ground, there are the usual urban issues to consider: site of roads, rail, hospitals, and the general terrain, to narrow down to one or two possible routes for the cable's trenches to follow. Also vital are the soil's physics and, in particular, its thermal properties. Knowledge of that environment is critical in the design and implementation of a successful underground power system. The ampacity of the cable is largely determined by its surrounding physical environment. The issues are simple enough. Electricity flowing through a conductor generates heat. Any resistance to that heat in the surrounding environment causes the cable to overheat. So this trapping of the heat has to be avoided or minimized. This could mean cable and trenches, or both, have to be larger, or the space between circuits made much wider. An unsuitable backfill also increases the temperature, shortening the life of the cables, and, at worst, leads to failures. Performance thermal backfill, designed by Geotherm, assists the heat to escape, resulting in cables operating at their optimum temperature. There is technology available to guard the cables, reduce the likelihood of power failure, and protect the energy provider's asset. At the forefront of this technology is Geotherm Australasia. Geotherm offers a comprehensive technique to ensure maximum protection and the longevity of a power grid's arteries. Its unique asset, the cables transmitting the provider's product, energy, power.
That's significantly different.
Geotherm specializes in thermal property analysis, assessing beforehand the thermal properties of an underground cable's prospective environment. First of all, in thermal route surveys, testing the proposed route at regular intervals. Geotherm, utilizing technical developments from the international leader, Geotherm Incorporated of Canada, has taken the guesswork out of soil physics, and notably that of soil thermal resistivity, or TR as it's known. The thermal probes that Geotherm conducts in situ, testing for thermal resistivity and moisture content of the native soils, are also designed to identify poor soil. It's crucial information, enabling electrical engineers to design a total cable system layout with sound knowledge of the underground environment the cable is to thread through. Core samples of the native soils are collected and taken to Geotherm's laboratory for further analysis. Geotherm can perform tests on a range of materials, from native soil and clay to road base and sands.
Okay, no worries, no problem.
Depending on the native soil's TR, the next important outcome is the cable bedding and backfill to close the trench. A performance thermal backfill can be designed by Geotherm in the laboratory to serve as cable bedding and backfill for optimum performance. Drawing on the manufacturers of concrete-based products, Geotherm's new bedding will include a selection of natural materials in varying proportions. Using locally quarried materials, Geotherm will come up with the best possible mix as a backfill so as to maximise heat dissipation. As cable laying proceeds, the replacement backfill is double-checked. Quality assurance. The benefits of thermal backfill are now widely recognised by local councils and main roads departments, knowing it will not subside or break down or cause future problems. It facilitates ease of cable laying and reliability of power supply for the life of the project and is guaranteed to last to the last. Driving assets the harder to increase shareholder returns and, vitally, preserving the utility's major asset, the cables, supplying clients and communities with power.